Do you have the power? Unit 2, Linear and Exponential Functions. In the Ready, we're using subscript notation for sequences. In this example, we're given a sequence 5, 15, 45, 135. Here we can see how function notation compares to our subscript notation. The first term, f of 1 equals 5, and here, since it's a subscript, we'll say a sub 1 equals 5. A sub 2 equals 15, and a sub 3 equals 45. Looking at the same sequence, we can see that this sequence is multiplying by 3 each time. Our recursive rule in function notation is f of n equals f of n minus 1 times 3, where f of 1 equals 5. Or you could write it so that it's 3 times f of n minus 1. With subscript notation, the structure of the rule is the same. The only difference is, instead of saying f of n, we have a sub n, and instead of f of n minus 1, we have a sub n minus 1. Here you can see that we're still showing repeated multiplication by either putting times 3 after a sub n minus 1 or multiplying 3 to a sub n minus 1 in this way. And a sub 1 equals 5, just like f of 1 equals 5. Remember that the n minus 1 subscript represents the previous term. For example, to calculate the fifth term, a sub 5, you take the previous term, a sub 5 minus 1, or a sub 4, and you multiply by 3. With the explicit rule notation, if we start with the 0 term, now this 5 is not the 0 term. Whenever we have a list of numbers given to us in a sequence, the first term is the first term. If we were to work backwards, and instead of multiplying by 3 to move to the next term, divide by 3 to find the previous term, we'd find that the 0 term is 5/3. So f of 0, or a sub 0, is 5/3. Here we have the 0 term, then we have our common ratio, and then we have n, since we started with the 0 term. In subscript notation, we have a sub n equals 5/3 times 3 to the n power. Notice that the only difference is instead of having the notation f of n, we have the notation a sub n. When starting with the first term, the 5, we have the n minus 1, because it is the first term. The only difference between our function notation and our subscript notation is that instead of having f of n, we have a sub n minus 1. Think about how a sub n minus 1 represents the previous term in a sequence. So what would a sub n plus 1 represent? A sub n plus 1 would represent the term after a sub n. We could call this the next term. A sub n minus 1 is previous, a sub n is now, and a sub n plus 1 is the next. In the set, we're simplifying algebraic expressions using properties of exponents. Let's recall the properties of exponents that you learned in the task. We have the product rule. This is when you are multiplying like bases and you add the exponents. And the quotient rule, when you divide like bases, you subtract the exponents. Anything raised to the 0 power, remember, is 1. Negative exponents, so here we used the quotient rule, we subtracted and got a to the negative 2 power. We want to always leave our exponents as positive numbers. That means you need to rewrite it as 1 over a to the positive 2 power, or 1 over a squared. The power rule is when you multiply. Here we have 3x to the third. This whole quantity is being squared. 3 squared is 9, and here's where you multiply your exponents. Since you have two groups of 3 x's, you have 3 times 2, 6 x's. So we have 9 times x to the 6th power. So when you raise an exponent to a power, you multiply the exponents. In the Go section, you're solving two-step equations. We want to use inverse operations to undo the equations and solve for the given variables. We're going to solve these two equations simultaneously because they have the same structure. So in both cases, we want to isolate the variable. In other words, get x by itself. So we start with what's further away from the x. We'll add 7, and in this one, we want to subtract 5. Whatever we do to one side of the equation, we have to make sure we do to the other side of the equation too, to keep the equation balanced. Over here on the left, it gives us 2x equals 6, and on the right, 1/2 x equals 2. Here I'm noticing that the structure of both of these equations show a number being multiplied to x. Here 2 is being multiplied to x, and over here 1/2 is being multiplied to x. So we just need to divide the number away. We'll divide by 2 on both sides of the equation to make sure we retain that balance. And over here, we'll divide by 1/2 to get x by itself. 6 divided by 2 is 3. 2 divided by 1/2 is 4. Remember that dividing by 1/2 is equivalent to multiplying by 2.